Okay, so this lesson is about evaluating formulas, using variables, plugging variables into formulas, that sort of thing. So let's just start with what is a formula. When we're talking about a mathematical formula, what are we talking about? And this is an equation that has usually multiple variables. So variables are the letters that you see. And so there's usually more than one variable involved. And it's usually an equation that's representing a real world situation. So another term for these is a literal equation. And this comes from the fact that there are letters in the equation. So if you look up what literal means, it actually comes from Latin. I have it highlighted either from literalis or litera, which actually means letter. So, and one of the meanings of literal, which we don't often use, is that it just means it's related to letters. And that's how it's used in math. So literal equations are formulas that, they have multiple variables in them. That's why they're called literal equations. So most formulas that you see are related to geometry, like perimeter. You'll have area for various different shapes, like area of a triangle or a circle. There's circumference of a circle. The Pythagorean theorem is related to triangles. So most of our formulas relate to geometry, but there are other formulas like ones for money, simple interest and compound interest. There are other formulas out there. There's in various sciences, like if you're taking chemistry or physics, there's tons of formulas. Temperature conversions are another formula. We have distance equals rate times time. That's a formula. We have tons of formulas that we will be using. And so what I'm going to be doing is just showing you some of the most common ones, how to use them, describing how to interpret the letters and all that sort of thing, so that you're kind of getting some of the basics of algebra and understanding variables. So we're going to start with this example. We've got a trapezoid here. So this is a trapezoid, which means that you've got two parallel lines, and then the other sides are not parallel. They usually sort of look like triangles. And so our formula for a trapezoid is A equals 1/2 times B1 plus B2 and then times H. So I'm just going to rewrite this or kind of describe this formula and what this means. So when you see a number here, so the 1 and the 2 are subscripts. That's what we call them. And they are below the main letter, and these are used as labels. These are just labeling it as 1 and 2. And in the formula for a trapezoid, the B stands for base. So these are just numbering the bases by 1 and by 2. If you were trying to do something like this on a computer, you would use a underscore. So like you would type B underscore 1 or B underscore 2 in order to indicate that you've got a number below it. So that's the underscore is the same button as the minus on your keyboard. You just have to hit shift to get the underscore part of it. So when you see any formula or any equation, you've got numbers that are sort of under a number. Those are just labeling so that you know that there's a difference between these variables. The other thing about formulas or any equations is that if you've got a whole bunch of stuff linked together like this, and there's parentheses, it's always assumed that these are multiplied together. So you won't see the multiplication sign, but it's there. So like between here, we've got multiplication. This is 1/2 times, and then there's another multiplication by H here. So we have 3 things here that we're multiplying together. The B1 plus B2 is grouped together by the parentheses. So it's important to understand, what the equation is telling us and what we're doing, so that way you know what to do with it. So, are there any questions so far? And I forgot to say this at the beginning, but I do email out the notes that I have here in addition. So I have the recording, I email out the recording. I also email out the notes. So if you prefer to just watch and listen, and then you can have a copy of the notes, just print out what I email out, that's totally fine, or you can try to copy along and fill in later if you want, or just want to give you a heads up. So if you miss anything, this is recorded and you'll have the notes, so you can always go back. So if there's no questions about just what that formula means, now we're going to actually do the problem, which says find the area of the trapezoid shown below. So in our trapezoid here, the bases are the horizontal parts of our formula here, or our equation. So we've got two horizontal lines on our shape. We've got the 5 inches and the 4 inches labeled. And it doesn't matter which one is the first one and which one's the second one. It honestly doesn't matter. So we could just label this one as B1 and the other one is B2, or you can do it the other way around. Now the H in the trapezoid formula for the area is height. We try to use letters that represent the actual, that kind of match. So H for height, B for base, use a letter that matches the word of what it's representing. And so that's going to be our 2 inches right here. So if we're finding the area, we are using this formula, and the A is going to stand for area. And we are replacing B1, B2, and H with their values that we get from our picture. So you want to make sure that you put them in the correct spot. And we often refer to this as plugging in the values. Now, all math that we do is done vertically, so that's why I'm doing this underneath it. You're going to want to get into the habit of working vertically, because it will help keep your stuff organized. And that's just the way, that's our mathematical convention. That's how we show our work. So in our picture here, I've labeled B1 as 5. And when we use the formula, you don't have to use your units. You could just use the numbers, because we're just doing the mathy part. And then I have B2 labeled as 4. And then H is 2. And I'm putting a little dot there to indicate that multiplication by 2. So when we're indicating multiplying, we don't use an X, we use a dot when we're in algebra, because X is often used as a variable. So you're going to want to use the dot for multiplication. Now, to simplify this, we need to follow the order of operations. So our acronym for that is PEMDAS. And so the first thing that you do is the things in parentheses. So that means I need to do the 5 plus 4 before I do anything else, because that's the order of operations. So I've got A equals 1/2, and then 5 plus 4 is 9. So I've got 1/2 times 9, and then times 2. So now we basically have a lot of things multiplied together. And I could actually get rid of those parentheses with the 9 and I can just put another multiplication symbol because that's what it is. We just have these three things multiplied together. And so from here, the next thing in the order of operations is to do the multiplication, and we want to go in order from left to right. And so we're going to do the 1/2 times 9. And when you're multiplying a fraction times a whole number, you multiply the top of the fraction by the whole number. So it's going to be 1 times 9, which gives us 9. We're going to get 9 over 2. And then we have times 2. And then we need to multiply again, 9 over 2 times 2. So instead of doing 9 times 2, I'm actually going to try to reduce it first because that will be less work. So a whole number, you can write it as over 1 to create a fraction. And then you can cancel things out if it's on the top and the bottom. So I can cancel out those 2's on the top and the bottom, and that just gives me 9 over 1, or just 9. Now it says to find the area of the trapezoid, and whenever you have real world problems, you always want to give the units here. And area is always squared. It's always going to be whatever your unit is squared. So our area is 9 inches squared, or you can write it as 9 square inches that way. Either one of these would be a correct way to show the units, but we get squared units whenever we have area. Are there any questions? Okay. So here we've got another geometry problem. We've got area of a rectangle. So this is one of the formulas that you guys should have memorized, what area of a rectangle is. I don't expect you to know area of a trapezoid. You're not going to come, know that, but you should know area of a rectangle. So if you guys want to type that in the chat, what the formula is, that would be fantastic. Length by width. So it's your length times your width. So I use capital L so that it doesn't look like the number 1. Because my lowercase l's can look like the number 1. So I use a capital L here, but we use the symbols L and W for length and width. So it's length times width, or length by width. If you're doing word problems and you see the word by, that usually means multiplication. So that's a good thing to note when you've got word problems. And so length is usually the horizontal, and then width is usually, when you have a 2D object, width is usually, we usually make length the longest one, I should really say, and which is usually horizontal, and then width is the shorter end, I guess. So we're going to be multiplying here 7 1/6 yards times 3/4 yards. So I'm going to first just write that down. We're going to replace our values here. So we have 7 1/6 times 3/4. So with yards, we usually do use mixed numbers when you do any kind of thing with construction and geometry in real life. But in math, we don't really like to work with mixed numbers because they're not easy to do arithmetic with. So we need to convert the 7 1/6 to an improper fraction before we do the math. So you do that by taking the whole number part you multiply it by the denominator, and then you add the numerator, and that will give you your new numerator. So we would have 7 times 6 plus 1. So 7 times 6 is 42, and then you add 1, and that gives you 43. So this is 43 over 6. And we're going to multiply this by 3 over 4. So when you're multiplying fractions, you're multiplying straight across. And I like to try to reduce first before I multiply, just so I have smaller numbers to work with. And when you reduce fractions, you have to make sure that you reduce something on top and something on the bottom. So I immediately see that out of 3 and 6, I can divide both of those numbers by 3. So if I divide 3 by 3, I get a 1. And 6 divided by 3 gives me 2. So I can replace those with a 1 and a 2 and reduce that. Now the 43, I think that is a prime number. I can't off the top of my head think of any numbers that go evenly into 43. I could tell you for sure that 2 is not going to divide into it, and 4. And so we're not going to be able to reduce any more numbers, because that's the only ones in the denominator that I'd really be able to try to reduce out of 43, and it's just not going to work. So we're going to multiply these numbers straight across, and this gives us our area of 43 times 1, so it's just 43, and then in the bottom 2 times 4, which is 8. Now, in math, when you have fractions, we would just leave it as 43 over 8. But when you have word problems, you generally want to make it a mixed number again when it's something with geometry, because that's just how we use these numbers in real life. You know, we wouldn't write it as you wouldn't go to somebody and say, I need to build a deck that has an area of 43 over 8 square yards. You would use a mixed number, or you might use some decimals there. So we want to convert this back to a mixed number just because that's convention for a problem like this. And to do that, you divide, and then you figure out how much left over you have. So you say, well, how many times does 8 go into 43? You're basically doing long division and then figuring out your remainder. So 8 times 5 gives us 40, and then we would have 3 left over. So this would be a whole number of 5 and then 3/8 left over. So it's 5 and 3/8, and our units here are square yards. So you can write it like this with a 2 on your unit to indicate that it's squared, or you can say 5 and 3/8 square yards like this. But you want to include your units whenever you have a problem that has units, which is, you know, even if it's not a word problem per se, you've got some units here, so that's connecting it to the real world. And so you want to include those units there. Are there any questions? Okay. Another geometry, because these are the most common. This is a sphere. So for something in 3D, you're always getting volume. And so volume of the sphere, like you probably have area of a circle memorized, but probably not volume of a sphere. And so it is 4/3 pi r cubed. So I wanted to do this one so that we can talk about pi. So pi is a special symbol. It's a specific number. I'm sure you've heard about pi. You know, you probably know that it's 3.14 and then a whole bunch of digits. So pi is a number that goes on forever. And usually for most calculations, you can approximate it as 3.14. So 3.14 is usually good enough for a calculation like this. Some calculators have a built-in button for pi, and then that will use as many decimals as they have calculated into the calculator. So my scientific calculator that I have has a button for pi, and it gives me 3.141592654. So it has a lot more decimals there. But if you don't have a pi button on your calculator, you can just use 3.14. So it's just a special number that has a special symbol because it shows up a lot in various formulas. You'll see it in circumference of a circle, area of a circle, volume of a sphere. So because that same number shows up so many times, that's why it has its own special symbol. So the R here is radius, and they've got that label as 1/2 yards. So we're going to use V for volume, and it's 4/3 times pi, and then it's 1/2 cubed. So when you are cubing a fraction like 1/2, you cube the number on the top and the number on the bottom. So you would do 1 to the 3rd power and 2 to the 3rd power. And when we talk about that order of operations here, let me write that down again. Order of operations is PEMDAS. We're doing the exponent part first because we don't have any parentheses with things going on inside the parentheses. So the next part is the exponent. So we want to do that first. So we have 4/3 pi times, and that's going to be 1/8. So 1 to the 3rd power is 1 times 1 times 1. And then 2 to the 3rd power is 2 times 2 times 2. On your calculator, there's usually a button for this. And if you were to try to type like an exponent, it is like if you wanted to do 2 to the 3rd, you would type it as 2, and then there's like a caret button that you can use. That's what my calculator has. That's called a caret, that sideways less than or greater than symbol there. So that's called a caret. So my calculator has that button, meaning exponent. And that's the same thing that you can use on the keyboard as well. So if you're in Alex and you're trying to get an exponent, you can use that. It's Shift 6 because that symbol is found above the 6 on the keyboard, and that can get you an exponent. So 2 to the 3rd gives us 8. So when we take the 1/2 to the 3rd power, we get 1/8. So now we're moving on to our multiplication, and we can do the multiplication of the fractions before we throw pi in there, because pi is like its own little symbol, so we can deal with the fraction stuff first. And I can reduce. I can divide the 4/4 and the 8/4, which would give me a 2. So that makes it a little bit easier here. And so what we're looking at is we've got 1/3, and I could rearrange these times 1/2 and then times pi. So you could rearrange the order of your multiplication, and that is called the commutative property. So that allows us to kind of put the pi in the back and just work with our numbers that we have. And so when you multiply that, you get 1/6 pi. So if the problem wanted the exact value, this is what you would see, or this is what you would say. So if it wanted the exact value, we would say 1/6 pi, or we might put pi/6. Because if we try to use the decimal version for pi, we then have to approximate and round, and it's no longer the exact value. So you kind of have to look at the wording to see, is it wanting the exact value? If it does, like if you're in Alex, it will give you the pi symbol in the little, when you click inside the box to enter your answer, it gives you a box to the right with like things you can click like to get fractions and stuff like that. So if it wants you to put pi in your answer, you'll see pi as one of your options that you can click. And that will tell you, okay, I need to leave it in this form with the exact value. If it's not wanting an exact value, you're usually told what to round to. And usually we round to 2 decimal places for something like this. So if we are going to approximate this with a decimal, you would have 1/6, and then we could use 3.14. So a fraction is just dividing. So if you were to put this in your calculator, you would do 1 divided by 6 and then times 3.14. And then we get some really nasty decimal here. Actually, it just kind of goes on forever. I get 0.523 into 3 repeats. So a repeating decimal you can indicate with a line on top. That's if I use 3.14. If I use my pi button, I get a different number. So if I did with my pi button, this would give me 0.523598776, and it goes on forever. But if we're rounding to 2 decimal places, so when you round, I like to put a little line where I'm rounding. You look at the number after the line, and if it's 5 or higher, you round up. So in both of these cases, the number after it is 3, so we don't round up, and so we could approximate this as 0.52. And you can see that you get the same approximation whether you use 3.14 or you use more decimals. We got the same value when we round. So our volume is either 1/6 pi, 1/6 pi, and then for volume, it's always cubed, or we can use our approximation 0.52 yards cubed. As soon as you have pi involved, you're not really going to make your answer a fraction because pi can't be written as a fraction. So you either leave it with the pi or you make it a decimal, and you have to do some sort of rounding. Are there any questions? Okay, so I've got one more example. This first lesson is not too long, but I will tell you for future weeks, these are usually can be up to an hour long just because it takes a while to explain all the algebra we're going to be getting into. This stuff, first week is not too bad. So this is my last example. We are converting a temperature from Fahrenheit to Celsius. And so we've got this formula C, standing for Celsius, equals 5/9, and then in parentheses, F minus 32. So we're going to convert both 77 degrees Fahrenheit and -40 degrees Fahrenheit to the Celsius value. So we're going to do 2 conversions here. So we'll start with 77. So I'm going to be replacing F with 77. And order of operations says I need to do that subtraction inside the parentheses first. So 77 minus 32. So that gives us C equals 5/9 times 45. So I've got 5/9 times 45, and I'm going to rewrite 45 as a fraction over 1 so that I can do some reducing here. Because I know that 45 and 9, I can divide those both by 9. Knowing your times tables, makes your life so much easier when you're doing algebra. So if you don't really know your times tables, like up to tens, like, you know, when you had to memorize them back in elementary school, it's worth your time to practice them, because it will make things easier for you, because you can instantly see, if you know those, you know what number you can divide evenly into them, and you don't have to do trial and error with your calculator. So I can divide 45 and 9 both by 9. So 9 divided by 9 is 1, and 45 divided by 9 is 5. So when I'm multiplying these fractions, I end up with 5 times 5 over 1 times 1. So it's just 5 times 5, which is 25. So 77 degrees Fahrenheit is 25 degrees Celsius. So now we're going to convert the negative 40. So I, again, just place negative 40 where the F goes, because that's the Fahrenheit temperature. And we've got a negative 40 minus 32. So you're getting more negative. And so that's going to be a negative 72. So when you've got negatives minus something else, it's like you're adding the numbers and then they're staying negative. So 40 plus 32 is 72, and then it's going to be negative. You can also just do this on your calculator. Now, again, I'm going to make that negative 72 a fraction so I can reduce this. Now, if you did a problem like this and it doesn't reduce, then we usually convert it to decimal, because when you're giving temperatures, you don't give temperatures with fractions, you might give it with decimals. But in both of these cases, these will give us whole numbers, so we don't have to worry about that. So I can write my negative 72 over 1 to make it a fraction here. And I know that I can divide negative 72 by 9. So 9 divided by 9 is 1. Negative 72 by 9 is a negative 8. So I'm replacing negative 72 with negative 8. So when we multiply across, we get 5 times negative 8. So this is not 5 minus 8. Remember, there's that multiplication sign. We're multiplying here. So that gives us negative 40. And then the denominator is just 1. So I can, did I do my math right there? That comes out to negative 40 again. I'm looking at that, I'm like, huh. I don't see any error in my math. I'm gonna just double check it on the calculator. Yep, that comes out to negative 40. So apparently negative 40 Fahrenheit is also negative 40 Celsius, which is very interesting. So there we go. So sometimes you have to double check yourself. If you think of it, you know, when you've got problems like this, any type of word problem, if you get a number that you think is a little funny and you're like, is that right? You know, it's always worth double checking yourself just to make sure that you've done everything right. You know, do it a second time, because you might have accidentally made a mistake somewhere, but I've checked everything. It's negative 40. They just happen to negative 40 Fahrenheit is the same as negative 40 Celsius, which is a very interesting relationship there. So this is basically how we use formulas, and what you'd be doing the formula with is you're plugging numbers in. Later on, you'll be solving formulas for other variables. So you can take like the formula here for temperature and solve it for F. So that way you plug in a Celsius temperature and convert it to Fahrenheit. So that's one of the reasons why algebra is kind of nice, is that if you know one formula, but that's not, you don't want your Celsius, you want to go to Fahrenheit, you can solve it and do it in the other direction. So are there any questions? Okay, so before we end for tonight, I just want to share just the course screen, because I have an announcement that I've sent this announcement out yesterday, because I noticed some people were asking me, you do not need to do the start your path here or any of this kind of stuff. We're not expecting you to do this. We're not expecting you to get all 765 topics or anything like that. Everything that you need to do is you click here, and then there's going to be the ebook that you'll be clicking on. And then there's also a line that says assignments, and that's what you're going to be clicking on. So the main page here, completely ignore it because it's too much to do in 8 weeks. Maybe if you took this class for like a 16-week class, a normal class, you'd be doing this, but for 8 weeks, it's way too much. So you don't need to do this. You only need to do the assignments that are through this button. And there is a tutorial in the weekly content here on navigating and using Alex that shows you how to find the assignments and everything. So I would recommend that if you haven't gone through that tutorial, you go through that tutorial so that you're familiar with the platform. And then if you're getting problems with entering in numbers and stuff like that, you can click on one of these. These are tips and tricks for like how to graph, how to do various things inside Alex. So just wanted to also show that to you guys. So that way you're not doing too much work before, I don't want you to go deep into the class doing the wrong stuff. So I just wanted to show that. Any questions on that? Is it possible to do a sample of a problem with multiple brackets? Sure thing. I can do that. Let me just throw that. Let me throw up a blank slide. And share my screen again. Okay, so I'm going to just make up this problem. I have no idea what this is going to, what the answer is going to be. It might be really nasty, but I'm going to make it up. I've got a request of something with brackets. So we'll do -2 plus 5 times, let's say 4 squared minus 5 plus 6 squared again plus 10. I have no idea what this is going to come out to, but I've got some squares, various things. So this is an order of operations problem. And so the first step of order of operations is parentheses, which includes brackets, and you work inside out. So we've got one set of brackets right here, but we've got a set of parentheses inside there. We have to work inside out. So we need to do the parentheses 5 plus 6 first before we do anything else. So I'm going to highlight that. This is the first thing that we need to do. So you're working inside out. So everything else just gets rewritten, and you always rewrite it. Don't skip, don't get messy here or anything like that. Make sure you copy everything down. So 5 plus 6 is 11. So this gives us 11 squared. So we have -2 plus 5, and then in brackets 4 squared minus 11 squared. And then we have plus 10. So we are still working inside the brackets, but you have to simplify the brackets down to a number before you move out of the brackets. So inside there, following the order of operations, we did the parentheses, next is the exponents. So we're going to do 4 squared, and then we're also going to do 11 squared. We can do those at the same time because they're separated by a minus sign. So if they're separated by a plus or minus, then they're different terms, and you can do those at the same time. So I've got -2 plus 5, my brackets. 4 squared is 16, and 11 squared is 121. So I am still working inside the brackets here, but I need to get that down to a single number before I do anything else. So next we have to do our subtraction, because in the order of operations, the exponents had to happen before the subtraction. So we have to do that subtraction next, because that's all we have left inside our brackets. So I've got -2 plus 5, and then my bracket, and I'm going to do this on a calculator. That gives me -105, and then plus 10. So when you have just a number inside brackets, you can just convert those to parentheses, and that's multiplication that we have going on here. So now we have addition and multiplication always happens first. So order of operations, that M is before the addition. So our next step, because we finished the parentheses step, so our next step now is to do this multiplication, to multiply 5 times -105, which definitely do it on my calculator. So I've got -2 plus, that gives me -525 plus 10. And now all we have left here is addition, or if you wanted to look at it this way, if you're adding a negative, that's the same thing as subtracting. So we've got a -2 minus 525 plus 10. Regardless of whether it's adding a negative or subtracting, you have to go left to right. So if you have subtraction and addition, you have to go left to right. So I would not do 525 plus 10 first. That would be incorrect. So in the order of operations here, the addition and subtraction are the same step, because addition can be written, or subtraction is adding a negative. It's the same thing as addition, it's just with a negative number. So those are basically the same thing. So those have to happen left to right. So I need to do the -2 minus 525 first, which will give me -527. And then I have plus 10. So I'm going to highlight that I did. And when you're taking notes, highlighters can be, or color coding can be your friend to kind of indicate what you did. So you see where you went from step to step to step and what changed. So now we have -527 plus 10. And so now we're going to add those together and we get our final answer of -517. So we've got only one operation here. So there's no choice. That's what you're doing. And then that gets you your final answer. So if it's helpful, write down our little acronym for the order of operations, but color code, kind of, use brackets or whatever so that you see things that are embedded and you make sure you work inside out. Simplify inside a set of parentheses before you move outside of it to simplify the next part. And you keep going until you get a number and then you move out. So you're really diving deep into embedded parentheses and moving your way out. And then you're following the order of operations every time. Multiplication and division is also at the same level. So those also have to do left to right. So I will also box these So division is defined as multiplying the reciprocal. So that is why that one is also done left to right, because they're basically the same thing. It's just rewriting division as multiplication. So does that help you with that question you had on the problem with multiple brackets? Perfect. Are there other questions? What type of calculator should we be working with? That is a great question. I'm going to stop sharing so you can show you what calculator I'm using. So this is, because I have my my virtual background, you can't see it. Let me turn my virtual background off so you can actually see the calculator. Okay, there we go. So I am using the TI-30X2S. I think this was like 12 bucks. It might be up to 15 bucks. I bought this a while back. It's got everything you need. If you're going into engineering, you might want a graphing calculator, but if you're not, this is good enough. It's got everything you need. Now, if you don't want to buy a calculator, and I'm going to type this into the chat, there is a website, desmos.com, and let me actually open that up and then share my screen again and show you the website. So Desmos is a fantastic website. You don't need a code. You don't need to sign up or anything. There's a graphing calculator. And then if you go to math tools, there's a scientific calculator. So what's nice about this calculator is that it has a fraction button. So if you're not good at fractions and you wanted to do, let's say we had that 5/9 times 45, you can just type that in and then it gives you your answer. And if it's something that doesn't come out nicely, it will give you a decimal, but then you hit this button and it will convert it to a fraction for you. So if you're not good at fractions, the TI-32S that I have can also do fractions, but Desmos does it easier than my hand calculator. So this calculator does everything you need. It's got absolute values, it's got exponents, it's got square roots, it's got pi. You won't really need this part. At near the end of the class, weeks 7 and 8, you'll be using this e to the x, this ln, which is natural log. You'll be using these buttons weeks 7 and 8. But for weeks 1 through 6, everything you need is on this main thing. So you can use this, you can bookmark this, and you don't have to pay for it. It's completely free. And then half the class we do graphing. So I'm going to be showing a lot of stuff in this graphing calculator. So having this bookmarked once we start getting to the graphing stuff is going to be really helpful for you. It'll make the quizzes go easier because you can, use this and then answer the questions on the quiz and stuff. So, even if you have a hand calculator that you like, this website, Desmos, is fantastic for the graphing that we'll be doing later. And there's no reason you don't have to buy like a $120 or $150 graphing calculator, because if you're only going to use it for this class and you're just doing basic graphing, there's no reason to buy a special calculator for that. Other questions? Okay, well, I haven't looked at the survey results yet to see if there's a different time that's popular, but I'm probably going to keep it at this time unless that survey that I sent out, there's a different time that seems to have more people that can attend. But I mean, we've got good attendance with this one, so I'll let you guys know Wednesday. When I send out my week 2 announcement, I always put in the announcement what time and topic the next live session is. Oh, excellent question. If you've got an easy question like 5 divided by 0, do you have to show your work for that? No, you don't have to show. If it's something that you can do in your head in one step, you don't need to show work for that. I would like to see work for things that are more than one step. Just, it's a good practice, even if it seems too easy and you can do it in your head, and because all you need to do is like 2 things. It's worth getting into the habit of writing it down, because we're going to very quickly get to parts in the class that you can't do in your head. So it's good to get in the habit of writing it down just to be, safe. But yeah, if it's a one step like division or something like that, yeah, you don't need to bother writing that down. Other questions?
I started working ahead on the homework for the I think it was the one that had the it's like a quiz with the it was a guy going home, I think going back and forth to and fro from work,
Mm-hmm.
and I was having trouble modeling the problem, finding a good equation to model the problem with. Maybe I'm just missing something obvious, but it's just
Do you happen to remember which?
I'm trying to bring it up. I actually got I was like I realized I double booked myself tonight for a church activity, so I came back. Oh, dang it. So I just I didn't want to like be a jerk and like go and then immediately leave, so I kind of stayed for a bit and then like hurry and drove home. Let's see. I'm on the wrong course. One second.
Yeah, let's see if I can find it too.
You might be. Maybe my computer logged me out. Cool. Oh
It
wait, I'll try the other browser.
does time you out very quickly, unfortunately, and there's nothing that I can do to change that.
That means that the people that made Blackboard have a lot of confidence in the security of their tokens. That's why they log you out so quickly, because they're so no.
Yeah.
That shows the level of confidence there. Let's see. I'm so bad at navigating this Blackboard. I apologize. I should have had a. If someone else has their question phrased, please go
Yeah, I
before
don't
me.
see anyone else in the chat with
Okay,
a question.
week one. I think it was it the quiz?
Oh, I found it. So,
I still don't have it up.
okay. So it should be on your screen now. I've got Darren drives to
Yes.
school in a rush hour traffic, averages 25 miles per hour. He returns home in mid-afternoon when there's less traffic and averages 50 miles per hour. So you guys will have the same question. This is on number 4 out of the mini assignments, and this is question 5. And so everybody's going to get like a similar question, but different numbers.
Yeah.
So what is the distance between his home and school? The total traveling time is 1 hour 30 minutes. So on this, there like helps here, and usually there are helps that kind of walk you through it. But in this case, they're
That one
sort of
didn't have a help. Yeah.
yeah. This one they don't, because they're already sort of walking you through it with the parts here.
Yeah.
Okay, so we do not know the distance between his home and school. So going to school, we don't know distance, so that's going to be X. And again, returning home, we don't know. So both of those are going to be X. Now we need to put our time in hours. So like the 1 hour, 30 minutes has to be written as 1.5 hours. So our time here, we don't know how long it's took to get to school. So that's unknown, but we have this expression T equals D over R, your distance divided by rate. So, and when you click in here, you see that it tells you have to enter a fraction. It's giving you a hint there.
Yeah.
So that's going to be your distance divided by your speed, and that will give you your time. And we know how long it takes. Let's see. So we know returning home. We don't know how long that is, but we know that the total time is 1 hour, 30 minutes. Okay.
Right.
We're not going to use that just yet. So we're also for here, you're going to do x divided by 50. We will use that total time when we create our equation. Right now, we're just going to make this table here.
Yeah, the table I think maybe just threw me off.
Yeah, that can. And the table is, designed to kind of help organize yourself.
Yeah.
So this is where we're going to use the total time, because the total means you add them together. So it says total time, so this could be 1.5 is time to school, which we have as x over 25. And then time to home is x over 50, which it would help if I actually typed that right. Okay.
I guess I was just having trouble building the equation, so
Mhm.
it's just the two of the that expression,
Yes.
but plus two of them on one side.
Yes, so I will check. Ta-da. And then it's helping you solve this. So this is a problem that's designed to kind of help you learn how to solve a problem like this. Now on the quiz, if you get a problem like this, it's not going to be walking you through like this.
Yeah.
So you have to really understand what's going on here. And for that, the optional assignments are good. Like if you're like, okay, I kind of understood that, but I want more practice, do the optionals.
Mhm.
So, but yeah, they're telling you we're going to get rid of fractions. And so you want to multiply by the common denominator, which is 50 in this case, because we've got 25 and 50, and 50 is the common denominator. So I just typed that in. Okay, so on the left, I get to multiply that out. That's nice. So I can just do that on the calculator. Just walk through the same problem here. So that's 75. And then now this would be a step that I wouldn't want to just do in my head. I'd probably want to write this down on paper.
Mhm.
But since I'm just sharing this, I'll just kind of talk you through it. And then when you guys do the problem, I recommend that you write everything down. But we're going to do 50 times the x over 25. And when you reduce that, you're doing 50 divided by 25, which is 2. So that's going to end up with a 2x. And then when you do 50 times x over 50, the 50s cancel and you're left with just the x on top, which is why they have just x there.
Right. Oh, okay. Right. It's
Yes.
50 over 1.
Yeah. And now they want you to solve. So they're saying, okay, basically do the final step here. They're skipping some steps because it just says, well, what is x? X equals what? So we would have to do 2x plus x, which is 3x, and then divide both sides of the equation by 3. So there are some steps here they're not having you enter that you would have to do on paper. But that should be 25. And then for word problems, you always want to write your word problem as a sentence, a final sentence for word problems, because that puts it in context, adds the units. And if you have to go to take pre-calc, that you have to do that in pre-calculus, because pre-calculus is all word problems. So for anybody that has to go on to that class.
Was it all word problems here?
It is here. Like you learn the skills, but it's all applying the pre-calculus and in word problems.
Huh.
So x is 25. So it says, okay, he travels a distance of what from home to school. So going to school and home, so it's x either way. So it's 25 miles. That's what this answer means. And then, ta-da!
Yeah.
Yeah, so the problems that don't walk you through this, those are the ones that have the additional helps, because they're not kind of walking you through step by step. So there's the guided solution.
Yeah.
There's an example. There's a lot more helps that you can use. And if you run out of, you can do these unlimited times, but some questions only allow you one chance. And if that occurs, just submit the assignment, and then you can open the assignment another time, and then you only need to redo the ones you got wrong. So I know that occasionally there are some that don't give you a second attempt. So you just need to, do the assignment, and then when you redo it again, you'll get another chance at that.
Okay.
Any other questions?
How long until we get to matrices?
You will not get those in this class.
Really?
That's in pre-calculus.
I shouldn't even be here. I've already taken pre-calculus. I didn't talk. So they're like, you didn't have college algebra on your thing.
It didn't transfer, or you didn't take
Well,
a class like
I never
that?
took college algebra in college because I took pre-calculus in high school and then I reviewed it again in
That's,
college years ago. I
huh,
probably need to review it again.
that's you can, there's things called CLEP tests
Uh-huh.
where you basically take a test and then it gives you credit for the course.
Mhm.
So, but I think you have to pay for that.
Mhm.
So I don't know, but that might be something to look into if you're like, oh,
Mhm.
I've already taken this, but it also might be a good refresher. So,
Maybe. Yeah, I definitely need a refresher on pre-calc. Anyways. Huh. But I thought I did matrices back in, I think, algebra 2 in high school, right?
yes, yeah.
This,
If our college algebra class was not 8 weeks, we'd probably get to matrices right at the end.
uh-huh.
But there's so much to cover. We don't have time to do it in this class.
Dang it. So I won't understand how a transformation matrix works in this class. Like,
No, no.
oh, dang. Okay. I'll be quiet now in case anyone else has other questions.
I
Thank
don't
you.
see anybody else asking any questions in the chat. So, all right. And somebody had asked for closed captioning, and I don't know how to turn that on. I only turned it on because somebody asked for it. So I will try to figure out how to get that turned on future. So that way it's always on the recording for anybody who needs it. So. All right. Well, I'll let you guys go. Sunday night, you got to get your discussions in. Make sure you're replied. Well, your replies are due Tuesday, but if you haven't participated in the discussion, make sure you guys do that. So you guys have a great night. Hopefully I'll see you at the next live. And let me know if you guys run into any issues. You can email me. You can, if you signed up for Remind, you can send me a message on Remind. I'm pretty quick to respond there. So. All right. Take care, everybody. You've got quite the setup. You have more screens than I do, so I'm pretty impressed.
So these little cameras that I'm using for the overhead view, I reverse engineered.
Oh, that's pretty fantastic.
Yeah. Anyways.
All right. Bye.
Bye.